I am talking about Lidar today. I'm the GIS manager for North Carolina Emergency Management, the Risk Management Office, and we have the floodplain mapping program, and we also have the Lidar collection program, amidst many other things that have been talked about at this conference. If you have questions about any of those, I'd be happy to cover those some other time. But we're in the midst of doing a second statewide Lidar collection, and I would like to share some information. So this is the history of North Carolina with Lidar. We have a collection that started in 2000. It went through 2005. It was a 3-meter post-spacing data set. And I've talked about this over the years, so I kind of wanted to pare this back down to what we're using it for now. We actually have building footprints for the entire state that we collected. Some poor person drew them off of imagery in 2010 before we had all the imagery that we have now. They all hate me now, but that's okay. But where the goal here is to actually use the Lidar information to upgrade the building footprints. We also want to try to get first floor elevation and highest and lowest adjacent grade. So the first floor elevation is a different beast. We don't get that directly off the Lidar. We do it outside the 100-year floodplain statistically. We collect in the field anything in the 100-year floodplain. All the roads that we have, NCDOT is a huge part of our program. They work in conjunction with us to help with the QC process. They use this to help determine where the road networks are at, and they are coming up with new and better ways as the data gets better and better to use that inside of NCDOT. NCDOT is kind of a massive group of people, so they're using it through all different sets within the agency, the hydrology group for structures and the roads group, and then we have photogrammetry who works with us. Flooding is the reason that we actually can pay for this data. So the floodplain mapping program, we determined with the original collection that it was highly beneficial to have this data to determine where the flood zones were at. And we have engineers in our office that use this to figure out where all those areas are and to keep people safe. And then we do have a mobile collection that's along the coast that we did before sea level rise was illegal. And we actually we have that data set that's just on the road networks that was mobilely driven. All the data is publicly available on this website, rmp.nc.gov. You know, it makes a lot of sense. It sounds exactly like something I would do. STD is not a disease. It stands for Spatial Data Download. It is access to the public. It is all of the data that we have available that you can go do a clip and ship. I do not have a big enough network to allow you to download the entire state at one time. You do have to send me a drive if you want something of that nature. And then John Dorman will not download the data, but he will tell me to do it. We will download that data for you and send it to you. You can do small areas, and the goal was twofold. One was for engineers and surveyors to be able to get small areas without having to deal with a monstrous set of data. So instead of having many, many tiles that you had to clip out and figure out what information was available when the tools were not really there and readily available in the past, you could clip out those small areas now and get that information. Or if you need the whole county, we will send you a drive of the whole county. Or you can go to Kirk's website and download it from there, which is why I sent it to him. We do use it for the DIMS for the imagery, and you will notice that the Lidar collection is every 5 years right now, is a 5-year plan. We do not do it consistently, so once we get the baseline done for the Lidar, we will actually look at what areas have the most change. We will determine what Lidar needs to be flown after that. Imagery is used a little differently. They have 4 phases. That is actually run through CGIA. I believe they're talking about it today. But they do use the Lidar as a baseline for that, and it's offset so that the Lidar's done when they fly the next flight year. And then floodplain delineations, which I talked about. This is the old map. This is the status of where we are now. So what we have done is we have done phase 1 through 3. That runs up to about Rockingham, Guilford, Randolph County. All of that data is available on the Spatial Data Download at this point in time. That data set is 2 points per meter. So originally we had a 3-meter post spacing, now we have 2 points per meter. With the new collection, we used a Geiger sensor, and the sensor changed significantly. So they took that 1 point of light that they were shooting at the ground, and they split it into 100. And then they have collector methods that on the plane can receive that data that makes a lot more sense. And there's a lot more technology to it than that, but that's the easiest way to explain it fast. So all of this data comes in, and they have the ability to fly really high and fly much faster and collect data much quicker. And the accuracy level is amazing to be able to fly that high. So with that, we have a new 8-point per meter collection. It was actually collected at 30 points per meter, and that was more than I could handle. So the 30-point per meter data set actually lives with the contractor, and then 8 points per meter is what is delivered to us. And we review that, and I'll talk about that in a minute. So these are just some current status overview of where we are in the process. This is, what is this? I can't see it from here. This is actually the classification for the road networks that's been done. And I did not set up my information correctly. So where we are right now is it is done by block. So one thing with the larger data sets to review in QC, we decided to not do it by county because you have to wait for unusual shapes to get finished. And they fly in these nice little blocks. So they deliver the data to us in blocks. We review it in blocks, and we provide it back, and they will deliver a final product that has all the derivatives in the county format, which will be stored with us. We do not duplicate along the boundaries. To support future, the goal was that 30 meter was to get utilities involved because 30 meter will support collecting distribution and transmission lines. So that was the goal there. This collection was flown at 17,000 feet because of the 30 meter. It does have 50% overlap. For phase 4, because we were using a new technology, it took a while to get money put together. So we had to get a lot of people to buy in. So we flew late. We stopped them flying mid-April because all the leaves were blooming. So they finished the collection this flying season. So half of phase 4 was done last flying season and half of phase 4 was done this flying season. Some of the things that we have to think about, and this is lesson learned from the new flights, is that we have to keep an eye on the weather. There were some things about the Geiger sensor that we thought it would do that it really doesn't. And one is you really need to fly at night. It's based on photons, and flying at night was just got you better data. So they ended up flying most of this at night. When you're flying that high, there are all sorts of new issues that you run into, like how fast the wind is at 17,000 feet versus how fast the wind is at 5,000 feet. So those were a lot of problems. Also, now you have cloud decks at different levels. So you can work with a certain amount of clouds, but not full cloud cover. So that's something we have to take into account as well. This was a really cool error. So they flew Lidar for phase 4 right after all the fires. And they came up with this anomaly, and we realized that it actually matched what had burned in the mountains. So we have realized that we can take this information from the flight that they've done, use the intensity, and pull out a polygon that shows where the fire had taken place out in the west. This is just an example of some of the overlap between the two different sets of information. This is a different process for Geiger, so it works a lot more like old photogrammetry than Lidar does, and they do a block adjustment on this. And then there were some control. Because we have this whole depth of points, so you have points from the ground through the trees on top of things, we were collecting control not only on the ground, which is a requirement for us, but also on top of objects to see how good the points were throughout the point cloud. And there was some issue actually finding some of that control if you were in areas that were just farmland. You didn't have a lot of information. But there was a ton of survey that was done. This is another lesson learned. We were working with the Lidar data set, and we're trying to use the new LAS 1.4 specs. And there was a scale factor that in the processing, they had just left it to all the digits that it had, was something like 16 digits. Well, as we tried to compress that data and as we tried to use that data in our systems, we realized it was killing our file size just for that one piece of data that had all those digits. So we had to have them go back and review how to pull those digits back to what the requirement for the project was so we wouldn't be lost in file size over something that's really minor. This is another set of a new perspective on the filters. So down in the bottom, this is actually an error. I have to tell you that I do these presentations and I tell you everything that's wrong with the data, but the data is actually fantastic. It is a beautiful set of information. So as we're going through and we're QCing this, we are finding things that don't work out well, but we're also realizing that we're finding errors that we've never seen before. We ended up sending the first delivery back 4 times because we found algorithm issues in how they were processing the data that we wanted them to fix from the beginning so that it would work all the way through. So this is one of the errors where it didn't class out this whole section, and we had to go back and have them fix a lot of these problems. It also had some density issues where it would pass, but the density was really low numbers, so we had to go back and review how these numbers were pulled through. There was also some lessons learned on how to look at the data. So if you look at the top, there's all those dots. Those dots are actually landscape mulch under trees. So if you're somebody who is going through and cleaning the data and you have all these dots in the data, you think there's something wrong with it, but that's actually where the ground is. We were never able to see this much detail before. So we had a bit of a learning curve on that. One of the other things we found was the ground was actually running up the front steps to the house. So we were catching the front steps on everybody's house and it was putting it in the ground level. Because this was such a small amount of points in the ground, we determined that we were going to leave this with the goal of being able to use this to determine where the front door was at so that we could get a first floor elevation more accurately. So this was another perk where we left it in the data because we thought it would end up helping us out. And we've talked a little bit about learning curves on how to use data and I'll talk about how we're QCing things a little differently now. But one of the biggest issues is if you use this amount of information and you try to generate a polygon, you get so many vertices in your polygons that you'll crash your system. So we were having to actually go in and when they put in these polygon lines, remove part of the vertices and actually lose some of the detail simply because we couldn't hold a polygon with that many points in it. So this is where I come in. That's all the technical stuff that the guys in the contractor side do. But this is where I come in for what the requirements are for the project and how we use the data at an end user perspective. So this is what we have as our list of deliverables. So we have the LiDAR points, the acquisition, the survey that has to go with it, the classification. We have the development of the DIMS. We have many levels of DIMS. We have a 3.125 foot, which is meter, that we send to USGS. We also have a 5 foot, a 10 foot, a 20 foot, and a 50 foot. And those are all DIM levels that are produced for different purposes, either within our office or for other groups that are using this information. All the data is delivered at 8 points per meter. Because it is such a dense set of data, we had to move from a 5,000 by 5,000 grid, statewide grid, to a 2,500 by 2,500. We actually couldn't open as many tiles as we could before, and panning through them to QC became a little tedious. It still is a little tedious, but we had to make those tiles smaller so that we could work with them a little better. I have not gone as far as Kirk and compressed all of these guys yet, which we need to work with them in when we QC in their native format, but the goal will be to compress all of these and have these available a little cleaner when you download them. And then building change detection was a new one. So because we had the building footprint level data set, we actually could add in this LiDAR data and we can see where there's new buildings and where buildings have been removed. So that is a perk that we knew was going to come with this because the data is so dense that we can derive the building footprints from the LiDAR data. So one of the other things that we have to deal with is specifications. So North Carolina has a set of specs that was done in 2013. LiDAR has changed significantly since that point in time. So really that is a linear collection, a traditional sensor set of specifications. And what we did for all of these specs, because USGS has a specification and then we're using ASPRS for the LAS header sets, we basically wrote out exemptions. And we said, because of the new technology, we're not going to be able to meet this spec but here's the compensation for it. So we spent a lot of time kind of going through this process. And we are the first set of Geiger LiDAR that has been done to this extent. There are 2 other projects that are going on in the nation, but ours is the largest at this point in time. So I have to give huge credit to NCDOT because they do the automated QC process for all of the data. They pull in every bit of data and they run a whole series of QC. And actually we add to this each year to figure out exactly what we're trying to find. Mostly what we're trying to find is elevation differences within a set grid size that are within each classification. So we know in the road network how far the points are from each other inside of that classification, and if it's off a certain amount, we actually want those removed or cleaned out. And then there are some new things that we found. One of the big ones was we found out that there's duplicate points in our data set. So we have to go back after the fact and remove all of those duplicate points. Our one saving grace is that they are exact duplicates, so we can just wipe out the other one. All right, so now you get to see pretty pictures, and this is my favorite part. So stream determination is one of the big ones that we have. So this is an 8 points per meter data set that was delivered. This is with the vegetation. And if I remove the vegetation, you can see that there's not great detail in the stream. This was a problem for us because that's why we need this, right? We need the streams. If I pulled in the unclassed data, it actually showed me that I could get a lot more detail out of this. So this was one of the pieces that we sent back originally, and we said, we need you to go through all the streams and we need you to pull in all those unclassed points and add them back to the ground, if they are ground points, which most of these are. Because it runs that algorithm, it takes things out automatically, but they can go through and they can clean these. So that was one piece that we did at the beginning to make sure that the data was as accurate as we needed it to be. So now I'm going to show you some comparisons between the existing data set, this is 2 points per meter, and the 8 point per meter data set. So this one is 2 points per meter. And this is the 3D of that area. And you can't see this great. But on the edges, you can see there's a lot of unclassed. The gray is an unclassed. And there's some information that's missing. And there's not a lot of detail in the road network. So this is with the vegetation removed. And you can see that there are some pockets up at the top where there's not that many points in between. So this is the 8 point per meter. And I'm going to back up so you can see those two compared to each other. You have much cleaner lines. You have just a lot more density. There's a building in there that was not collected in the last set. And then if we look at that three-dimensional, look at the detail in the roads and this building on the side. And I have not removed the unclassed from this, which means that there is just not that much that is impeding all the rest of the data. And this is a profile of the 2 points per meter, and this is a profile of the 8. So you can see the amount of data you're working with. Anybody know what this is? It's power line. All right, so here's the 2 point per meter at the top, 8 point per meter at the bottom. And one of the issues that we had originally was the ability to see through the vegetation. So that's one thing that we wanted to look at. If you look at the top, you can see the unclassed pieces. You can also see that there's large pockets in those triangles where it's flat. That means there's no data points there. And then I remove the unclassed. We do the 3D rendering, and we look at the profile of the two. There's just an immense amount of data that's available now that was not available before. Again, I want to say that the 2 point per meter data set is a fantastic set of data. It will do probably 80% of what everybody in this room needs it to do. But the 8 point per meter just gives us that next level. 2 points at the top, 8 points at the bottom. What I'm looking at here is the water line. So you can see the hydro line at the top. You can see the hydro line at the bottom. I'm going to pull in a little more detail. That's just the difference between the cleanliness of the data, how much tighter it is because of the density. And one of the things you can see is on the outside edge, that first set of water points, that has been included in this data, and you can almost see into the water at this point in time. Now, one thing to know about the water is that because it was flown at different times, the water is going to be in different places at different times. So even in the actual collection, your lines are not going to match. What North Carolina has done is we have said that it has to snap, but it can jump in elevation. So that lets us know that there is, a difference between those two lines. So you may come up with a river that has some sort of spike in it. And that's because it was flown from 2 different times. Normally, it's not going to snap cleanly. You're going to get something like it's way out here and it's got to snap back. So it should be you should be visually able to see it. All right, this is utility lines. Across this area, this is a distribution line. So these are things we were not sure we were going to be able to see, but you can see it very cleanly. This is just the difference between that culvert. I'm looking for the detail in the stream and around the areas of that culvert. And you can see if we remove the unclassed, the difference between the two. Again, I'm running out of time, so I'm going to go fast. This is some culvert information where we have the bridges. You can see through those trees. That was the goal, to be able to see that information. There's a culvert and just the detail that we have. And this is some building information that you're going to need to know. You can get highly detailed in this, but along those edges, because Geiger is flown in a circle and collects from every angle, the edges are a little fuzzy. So that's just something that's going to be visually a little different, but it still makes really pretty polygons. This was another fun one. You got stuff jacked up in the air. That's classified as a building. Is that wrong? No, we actually left these. But it's to know that these are water towers. We did have a lot of radio towers that showed up like this. Those we did say that had to be removed. But just the detail that you can see on that water tower. And then some software we're using. We're using ESP Analyst for the QC for the company that's doing the work. And then Topo Analyst is how we do the vertical horizontal QC. LP360 is how we bring in all the data, and we are using ArcGIS. And these are just different pieces that we're using. So we're cutting profiles in that LP360. We have terrain data sets that are also available with the data. And then a little bit of detail here, just what can be classed, the information that you can see. You can pull out those pipes between the building. Here's your utilities. So the biggest adjustments, and this is my last thing, I know I'm over, Jeff, I'm sorry, is that we did have to purchase a gigantic server. So we have a 500 terabyte server to actually hold all of the data and all the derivative products. It does hold some other stuff as well, but the Lidar is the biggest piece of that. We had to buy bigger computers to actually be able to process this at the same level that some of our contractors were processing the data. And then the time to QC has almost doubled just because it takes so long to pan and see all the data inside of the systems, and because we have so many more tiles. And then training new people is not the easiest thing to do, so we're working on getting a couple more people that could be up to par so that we can add them to the training. Harold is actually with ESP. He's the project manager for them doing the collection. He had that first set of slides, and then I am with risk management. 2016 data will be out probably by May is what we're looking for. They are in the midst of processing all of that. We're trying to get it all done. I'll have it all in hand by May. It may take me another month to get it on the website. It'll take me that amount of time to get it to Kirk and to USGS to put it on their systems as well. You good? Okay. Yep. They are flying that now. So what happened was, because we had to wait a year to fly the second part of Phase 4, we did Phase 4 and we tacked Phase 5 right behind it. I have funding for acquisition. I am waiting for the rest of the funding to process the data. So it will be out there and available, but we do have it in the process of flying right now. Yes, sir. So we'll have the LiDAR points and we'll have the DIMS and the terrain data sets. And then if there are other pieces that we produce, those of course will be available. I think this is a good point for you to tell me what you need. So if there's something that you're looking for specifically that you need that we can kind of do with low-hanging fruit, I will tell you that one of the things that we are probably going to do, well, I know we're going to do, by next hurricane season, so hopefully by June, I don't know if we're going to get it done by June or not, is we're doing 1-foot contours off the terrain data sets. We use that to determine where there's flooding during an event. So that's one piece that we will have, and we'll make those available. I don't. We're still working through. It will replace those, and don't use those. They're wonderful data. Don't use the 2 foots. You can use everything else. Don't use the 2 foots. The data won't hold a 2 foot. Yeah. The LiDAR classifications for the road networks, they actually went in and used the roads that were given to us by NCDOT and determined an offset, and then used the intensity imagery to draw in polygons, and that's how they classified the roads. So that the roads and the bridges are really the only ones that they didn't just use an algorithm for. Yes. 20 million for the state. But the return on investment from the original LiDAR data set was 7 to 1. So the return on investment was deemed high enough to make it valid to actually use. And the LiDAR is basically how we got the declaration for Hurricane Matthew. If we hadn't had that data set, we could not have had all the building footprint information that we needed to run the risk to actually get FEMA to run the declaration. So that in itself was very helpful. Other questions? I appreciate it. Thank you.